Okay, let's start going through last week's problem of the week. So the first two questions are basically definitions. So what's the difference between row echelon form and reduced row echelon form? So row echelon form you're looking for an augmented matrix with ones on the main diagonal and zeros down below. So you're looking for ones right here and then zeros in that lower left triangle. Everything else could be just numbers. Okay. So you're looking for something that looks like that. Okay. Reduced row echelon form. You are looking for something with an augmented matrix. Whoops. Okay. But now you're looking for ones on that main diagonal. Whoops. So one's on the main diagonal, and then two triangles of zeros. Okay? All right, for the next questions, um, okay, so for the third question, I hope that one should be obvious. Okay, so now let's go to the negative exponent one. Okay, just a second. So we have the following expression in negative with negative exponents. So that's 2a to the third, b to the third, all raised to the negative 3. Okay, usually what I tell my students is if it doesn't have an exponent, it does have an exponent. It's an exponent of 1. So what I do is I just put a 1 right next to the 2. Okay, since we have power to power here, we're going to raise every power on the inside by multiplication. So my first step would be this. So we multiply 1 times a negative 3, 3 times a negative 3, which would be negative 9, and then negative 9 on the b. Now, since everybody's a negative exponent, it goes down into the denominator. And once we move it down into the denominator, our exponents are defined as positive. The only other thing I need to do is make that 2 to the third a single integer. So that's going to be 2 times 2 times 2, which is 8. Like that. Okay. And that's it. All right. So the next one, we just have a little bit bigger exponential. Okay. So we're going to start out with 8 to the ninth BC. And that's going to be raised to the second. And then 2. Sorry. Stopped reading the question. Okay, so I'm going to simplify that. So what I would do is anything without an exponent, I'm going to put a 1 by to remind myself when I multiply. Okay, so I get this. Okay, so I'm going to multiply everybody by a power of 2, all the exponents by a 2. So that's going to be 8 squared, a to the 18th, b to the second, c to the second. Now I'm going to do the same thing, but now watch it. This guy's a negative. Okay, so that's going to be 2 to the negative 2. A, negative 2 times negative 2 is a positive 4. So it's no longer negative. So that's nice. And then B would be to the positive 20. And then C would be negative 8. Okay, so now we're going to look around and try to combine exponents if we can. So what I'm going to go ahead and do, okay, is I'm going to hold off on dealing with the numbers for now. So I'm just going to keep that 8 squared. Now I'm going to take a look at my base A's. So I have 18 plus 4, that's 22. B, that's 22, 20 plus 2. Okay, then C, 2, and negative 8 would be negative 6. And then I have my 2 to the negative 2. All right, so now I'm going to start working with my negative exponents. Now, this is just the way that I do things. You could do things in a different order and still be okay. So I'm going to do, everybody move down to the bottom that's negative. Move it down to the denominator. By definition, it is now positive. Okay, so now I'm going to start simplifying my numbers. So I have 64, that's 8 squared. 4. Now I can do some reducing. And there we go. That's it. We're done. Okay, so kind of cool. Lots of room to make mistakes though. So be careful. Okay. Okay, give you a minute. All right, here we go. Okay, so the last two questions have to do with domain. Okay. Or not the last two questions. Okay, so these are both rational functions. So with a rational function, you essentially have a big division problem. Okay, so when you divide, the only number you cannot divide by is 0. So we need to take these two functions, and I'm going to write them down both. And I'm going to go ahead and find the domain of both. Even though I know the second one asks for vertical asymptotes. Vertical asymptotes are incredibly related to domain. Okay. So we're going to find the domain of both of these. Okay, so we cannot divide by 0. So we need to figure out where our denominator is going to be 0. So we're going to just take our denominator, set it equal to 0. Okay, now these are both quadratics, so I need to either remember how to factor, how to use the quadratic formula, complete the square, things like that. These are both factorable though, so I'm going to use that method. So I need to think of two numbers. For the first one that multiply to 4 but add to give me negative 5, that would be negative 4 and negative 1. Okay, for the second one, I need two numbers that multiply to negative 5 but combine to give me negative 4. That would be negative 5 and a positive 1. Okay, so those two values give me 0 on the bottom. So I got to kick them out. Whoops. So take each of my factors, set them equal to 0. Okay. Now, so what this tells you is x cannot equal, for the first one, x cannot equal 4 and 1. For the second one, x cannot equal 5 and negative 1. Okay? So now, this one is asking you for domain. Okay? This one is asking you for vertical asymptotes. Okay? So when we do domain, we simply need to tell whoever is looking at our function, hey, this is what you cannot be, or this is what you can be. Since the answer is presented in interval notation, I'm telling the reader or the doer of the math what the problem can be. So the easiest way to get to interval notation is to draw a number line, negative infinity, positive infinity, 1, 4. I cannot go there, but I can go everywhere else. So I'm good to go here. I'm good to go in between here. I'm good to go here. So to write that in interval notation, you're going to go negative infinity to 1, union, 1 to 4, union, 4 to infinity. And that's it. It's a pretty long way to write domain, but it does work. Okay, for vertical asymptotes. Vertical asymptote on a graph is kind of like a wall that you cannot pass. Okay, so now the only way we cannot pass a wall is if our domain doesn't allow it and we cannot somehow remove it. Okay, so if I look at this guy, okay, what I can do is I can say, well, let's try to reduce that. Okay, now if I look at the factored form, I notice that I have an x plus 1 on the top and then an x plus 1 on the bottom. Okay, so what I can do is I can actually get rid of that x plus 1. So this is kind of looking like this graph. Now there will be a hole in the graph, which we'll talk about at a later time, but notice how this guy right here didn't move. Okay, you can't get rid of that factor. So that factor is associated with x cannot equal 5. So since we can't get rid of it, it is immovable. It is like a wall, which isn't really a very mathematical explanation, but that's what a vertical asymptote is. So I have a vertical asymptote at x equals 5. I cannot get rid of that factor. Okay? All right. Now, for the last two questions, it's about polar. Okay? So really quick, we're going to do it. Okay, remember two things. You probably need a calculator. Your calculator is going to be in degree mode because your answers are all in degrees. Okay? And you also need to know where your point lives in the quadrant. Okay? So let's handle the next two. We'll do them one at a time. All right, and the formulas are right there in case you don't remember them. Okay, so I have x, y is equal to 3, 4. All right, I'm going to use, and I want to put that into polar. So polar, remember, is r theta. Okay, so the formula for r squared is given. And the formula for theta is also given. Okay, so looking at your xy, okay, I'm just going to graph it. Oops. All right, so that's 3, 4, so that's going to be right here. Okay, so I'm going to find the radius of that first. So this length right here, we're going to use that formula, which is basically Pythagoras. Now, if you remember your Pythagorean triples, you're looking at it and going, well, Mrs. Harris, that's 5. Okay, so we know Okay. Now we need to do tangent. Okay. So this point right here is in quadrant 1. So whatever answer or angle we get for theta should be in quadrant 1. Okay. So we're going to get our calculators out and we're going to ask it, okay, tangent of theta is 4/3. We're going to use the tangent inverse. Okay. 53.13 degrees. Okay, so is that in the first quadrant? So first quadrant goes from 0 to 90 degrees. Looks like we're pretty good. And there we go. All right, so you need to be very careful with polar coordinates because they're not unique. Okay, you're going around and around in a circle. You can go clockwise, you can go counterclockwise, we can mess with the radius. All sorts of weird things can happen with polars. So just be very, very careful. So that's very important that you draw a graph. Okay, last one. Okay, we're going to use the same formula, same idea. So we have x comma y, negative 512. Okay. Got my formulas. Okay, I'm going to get my graph going. Okay, so this one's a little bit different. You'll notice that you have a negative x. So that's going to put you in the second quadrant. So negative 5, 12, 2, 4, 6, 8, 10. I made it a little too short, but that's okay. Let's see. 2, 4, 6, 8, 10, 12. So again, we're going to use Pythagoras. Okay, if you know your Pythagorean triples, you should be saying your r should be positive 13. Okay, so pi squared is 25 plus 144, 169, square root that is 13. Okay, cool. All right, now here comes the hard part, which is the tangent. Okay, tangent is in quadrant 2. All right, so I'm going to go ahead, use my calculator, do the same thing I've been doing. Okay, here we go. Okay, so my calculator very nicely kicked out a negative 67.38. Okay, that is in quadrant 4. I don't want to be in quadrant 4. I want to be in quadrant 2. So, whoops. So how am I going to get this angle right here? What do you think? Those two angles that I want form a straight line. So what do you think you're going to do? I think I'm going to add 180. Right? Because I want to make that straight line. So I get 112.6. 2. Okay. All right. So now I have my theta. It is in the appropriate quadrant, which is in quadrant 2, and I am done. Okay, remember this is from first semester. So if you don't remember, that's okay. First semester feels like it was forever and a day ago. If you were not here first semester, that's okay too. Text me, email me if you need help. Okay? Hope you found that helpful and have a great day.